Looks like we're starting up. Let's see, how bright does my light have to be? Good morning, Unexpected Maker. Thanks for hopping in. Guess that's looks fine now. Ah, thank you. 42 and rising, welcome. Carry 3 walls, welcome. Hi, Summersoft. As you know, I like to start just a little early to make sure everything gets going. Looks like we have Twitch and YouTube. Restream says Mixer and Periscope and LinkedIn are going as well. So I think we've got, yeah. Do you pronounce your W in your name as a V or a W? Hydrate. Yes, I've got my I've got my water here so that I can dump it on my keyboard. And again, I have water behind me as backup. Suavec. Okay. Awesome. Just got pinged on internal Slack. I already kicked the cat out. Well, the cat that doesn't like me talking. Unexpected Maker dumped the water at the start so we can get it over with. Hi, Charles. You'd like that, wouldn't you? I was surprised how the keyboard survived. I just let it dry out. Charles wisely says don't do that again. All right, I think everything's looking good. I've got the overhead going today, which is cool. So let me just flick to my off-screen thing briefly. It's Osh Park colors if you didn't realize it. All right, 2:01 on a Friday afternoon here in the Pacific Northwest. And I wanted to take some time to, maybe I should scooch closer to the mic. Might have to adjust my camera now. I have this really fancy system where I just scooch my webcam along my monitor until it's lined up right. Okay, so happy Friday afternoon, everyone. I'm Scott. I work for Adafruit on CircuitPython as a contractor. So first and foremost, huge shout out to Adafruit for continuing to pay everybody that they pay prior to the pandemic. Continue to do that. If you want to support Adafruit, you can do it indirectly by buying their stuff off DigiKey, who is still shipping. That's super helpful for us. And if you don't know how to find a particular Adafruit part on DigiKey, you can always go to adafruit.com. We now have buy at DigiKey buttons where you would also see add to cart. So that's another option. If you didn't know that, that's super cool. I thought it was really interesting. So I've started doing these deep dive streams. I like to call them deep dives because they're pretty informal. They end up being about 2 hours long usually, depending on how my voice lasts and whether my brain's still here because it's Friday afternoon. So yeah, I think I've kind of settled on this time. I like this time, 2 o'clock on Friday afternoons for me. Nobody else in Adafruit streams on Fridays, so this is a good time for me to do that. This week, I'm going to do a little bit of a different stream. Last time I've done a lot of talking the last couple weeks. I'm going to try splitting it up into 2 sections, or it's kind of 3 sections today. So the first section will be an unboxing. I showed a DigiKey box full of goodies on Show and Tell, and more than one person was like, you should do an unboxing. So I thought I'd do that, just talk over the stuff that I ordered. I ordered all the stuff myself. It's not free stuff from DigiKey, although because DigiKey pays Adafruit for things that I get obviously paid by Adafruit. So consider that some sort of disclosure. I don't get any price discounts or anything on DigiKey. So if you see some prices here, they're just whatever I pay. Mark says that's what I came for today, is the unboxing. So cool. So I figure we'll start with that, go over it. You might recognize some of the things in my box. And then after that, I did get a chance to work on the ESP32-S2 yesterday, and I'm feeling good about the progress that I made, and I have a better understanding of how to join CircuitPython to the ESP IDF. So I thought I would just kind of go over that. And then I had an issue at the end of yesterday. The linker was straight up seg faulting. And so I want to, if we have time on the stream, I'll start poking at that and see if we can't make more progress in the ESP32-S2. So that's the plan. If you have questions, I'm totally happy to take them as they come. If I suddenly disappear, it might be because OBS crashed, but last week was pretty good, and I think I'm using the same version that I used last week. They've been fixing lots of stuff. I think the cat will be fine, but in case you didn't know, one of my 2 cats is epileptic, so occasionally he does have seizures. He'll start by hissing, and then I usually mute the mic. So there's a small chance that'll happen, but he looks pretty peachy in his bed right now. But those of you who have done video chats with me or done the CircuitPython weekly meeting, which happens on Mondays at 11 a.m., you may have seen that happen. So just a heads up, probably not likely, but it does happen. Okay, and with that, let's go to the DigiKey docs. And again, just chime in with any questions that you have. So I ripped you can't see the whole box because it's actually quite a tall box. Actually, I'll go back to my just camera and I'll show you the box from this angle first. And I'll try not to hit my water onto my keyboard. So this is the DigiKey box. There's lots of stuff. I actually, I ripped the label off so my address isn't on there. And I took the top covering out. So I'm basically to the point where I'll just go through this stuff. So actually what I'll do is I won't actually put the box under the overhead because it's like pretty tall and hard to see. So I'll just start taking things out. Now the context I want to give you, put this there. The context I want to give you first before we go through this box. One of the projects that I've been working on separately. Hi, Nils. Thanks for joining. We're doing a DigiKey unboxing because I think I might be the first person. I don't know. We'll see. I bet Lady 8 has done one, though. Okay, let me get this not dropping in there. So this is an old Yamaha piano keyboard. And I really want to make it as a Bluetooth input and output. And the way that I imagine doing that is I'm going to intercept the key matrix. And I wanted to be able to prototype it with a breadboard. So I've been experimenting with very simple Osh Park designs. You can see here you can see my chickadee logo there on the Osh Park board, which is what the overhead thing is inspired by. Hey, it's finally in focus. So this is what I'm calling the dip flip chip, or flip dip, where this position is where the original dip would go. I'm sorry, I can try to lock it, but the problem is that I'm holding it up right now. Actually, maybe if I do this, since we'll be looking at some other stuff under here. There, and then I lock. Hopefully lock the lock the focus on blurry. How's that? There we go. Maybe that's locked. Oh, sorry if you had your speakers turned up way loud. I have the windows open, so I'm getting some pollen in, and maybe some noise as well. So yeah, this is what I'm calling a flip dip. If you see any boards on here that are purple that you're interested in buying from Oshpark, I'm happy to share the projects on Oshpark. I just don't always make them public, but I'm totally happy to, as long as you assume all risk about it. But the idea here is that the signals from the dip are in the normal spot here. There's a socket underneath, and then the real dip chip that was in on the board directly is now underneath this part. And then each signal that goes to the dip is brought out as a 2 by, in this case, 12 header, so that for every pin, it has an input and an output. And I'm just using cheap jumpers to basically connect all the things that I don't care to look at, but then I also can have, a pair of wires bringing it off to another board. So that's kind of my context. Like, I do a lot of software, so the hardware that I do buy off DigiKey has to do with my hobby stuff too. Okay, so let's look through the DigiKey box. And I will just grab the first thing, maybe two things. Okay, so this first thing here in the anti-static bag, maybe you can kind of see there's just a cut tape in there. And if we see what it says IC buffering, and that's entirely upside down. Hold on your horses. Now it's right side up. And it's very blue, which is interesting. But so this part is similar to a 7. It's a logic level shifter. I forget what the regular part is. There's one part that you would use to go from like 3.3 volts or from 5.5 volts down to 3.3 volts for eight lines. This one's a little bit different, and what the reason I had to order it is that the 760, so this is like a 7400 series. This stuff tells you like what process or speed it is, and then the 760 here says it's a logic level shifter where the output is an open drain, so it doesn't drive the high values, it only drives the low values. And I think I need this, because I have to prototype it still. I think I need this because the inputs from the key matrix in that dip chip are pulled up, so I only want to assert zeros then. Yeah, Robin says, is DigiKey shipping stuff? The only supplier I can get anything from is DF Robot. Yeah, they're shipping. I ordered this maybe like Sunday night, and it originally said it was supposed to come on Friday, but it actually came on Wednesday, just via USPS. But I also live in Seattle, so I think it's pretty well connected. Okay, that's the first thing. I'm gonna make a pile of stuff. The second thing, I will open this anti-static bag, but you can see it's a Nucleo board, which is an H7A. So this is the H7 series from ST. It's one of their fastest Cortex level microcontrollers. And you'll see a theme. I tend to collect dev boards. I have a whole bin full, but basically the idea is what would be interesting to run CircuitPython on. And this one is kind of interesting. It's kind of the higher end. Is it the higher end? Or I forget what end of the H7 line is, but we can pull it up. Let me just switch to this view. Maybe I can scooch it over so you can still see it there. Stm32 H7. we can just see where this fits in. They have a really good chart. So like dual core lines. The dual core line is interesting because that's what the new Arduino Portenta is. Actually, see, Unexpected Maker is like, how much was it? Well, I've got a reproduction of the cart that I bought. So spoilers, but it was $29 US. Spoilers, what else is in the bin? So the H7A is, let's see, it's here. So it's on their single core line, highest memory integration. It's got a TFT LCD driver with a JPEG codec, blah, blah, blah. So that's kind of neat. And that will go in my bin in case I probably won't do the work for that, but in case I need to test it, I'll now have it. Yeah, most STM Nucleo and Discovery boards are so cheap. Yeah, I actually have a couple others. So, okay, let's keep going because there's a lot in this thing. All right, 2 more. So let's see what this says. This is a tiny screen plus at SAMD20 eval board. I don't know if you can see that. So let's open this. This is a SAMD21 dev board. It's pretty old, but we have good support for SAMD21. And the reason that I wanted to pick this up actually is that it's a tiny circuit dev board from them. They've done some circuit Python work, but haven't actually made it onto our downloads page and into the repo. So I actually wanted to just pick it up and see if maybe I'll add board support for it. Just so that kind of trying to get more different manufacturers supporting that. So there's the Tiny Screen Plus, and it's super tiny. Let me grab, here's a feather. So here's the prototype IMX RT feather against it. So it's pretty small. And that's their deal. Tiny Circuits makes tiny circuits. And they do some really cool designs like tiny violin, tiny piano, and stuff like that. So, and they use SAMD21s. So I like to have it. So in case I need to test CircuitPython on it or do the port myself. All right, look at this one. Let's see, what does this say? Can you see that? I'll open it up in just a sec. It's the Nucleo L4 P5 ZG. If you watched Ask an Engineer on Wednesday, you know that this was Lamore's eye on NPI. She pinged me about it earlier this week, right before I made this order. And so because, as we were talking about, they're super cheap, $20 or $30. Hi, Carlos. And hi, Anton, too. I didn't say hi to you yet. But yeah, I'm having good luck with getting stuff. So this is the Stm32 L4 Series. And this is one of the newest chips from ST. And it's very similar to SAMD51, kind of in terms of being a Cortex M4 at 120 megahertz, which is exactly what the SAMD51 is as well. And the SRAM is 320 is a bit more than the SAMD, but not by that much. And then USB is the same. We've really trying to move into the high speed world, but this doesn't have high speed. But one thing it does have that the SAMD 51 doesn't is a TFT LCD driver, which again is kind of interesting to us because a lot of these higher end micros have it. So, okay. Let's keep going. As you know, I could just spend the whole time talking. So here's some stuff. These aren't dev boards. This one here is some more 24 position dip sockets. I bought 3 originally and already made that. Hi from Russia. I already made one of these, so I used two of the 3 I bought already, so I wanted to buy 3 more. And I did buy machined pinned versus I forget what it's called. But there's like two types of dip sockets, and I definitely prefer the machined pin ones. Okay, so that's one thing in my box. Let's see what this is. This says it's a shift register 8-bit 16 TSOP. So some of our dev boards don't have a ton of I/O. I'm like hiding in the dark here. So I wanted to just buy some shift registers to play around with. Hi, Demiti. David Boyd says single wipe and dual wipe. Yeah. Well, I think the other style has to do with the wipe, right? I don't know. I was experimenting, and the machine pins are more expensive, but they're cool. Anton says, look for the new IoT Discovery Node board with the L plus MCU and the ST Safe secure element on it. Oh, well, let's take a look. Okay. Next up is some machined headers. And David Boyd says machine pins are the future. I kind of agree. The reason that I've been going machine pins is that's what you need to fit well into a dip socket. Because I'm designing a PCB to go into a pin socket, I can't use normal headers because the pins themselves are too fat. Now, these ones are interesting. Maybe we can... I guess I can't convince it to focus. I don't know why I guess it's so blue because it's got a bamboo background. But these machine pins are interesting because on one side there's actually a little bit of a a thicker part. So these are meant to actually keep the board plugged in higher. So you solder on this side, and then there's some metal before the plastic bit. And that's interesting because what I found with my first flip dip is that the dip underneath is actually taller than the other side. Yeah, a boss or a detent or a ridge. That's a tough one. Yeah, I don't know what it's called. I forget. But basically, it's making the pins taller so that hopefully when the flip dip is in on the board itself, it will sit flat rather than at an angle like it is now. So I was gonna play around with that. Let's see what this is. This is the STM32 Curiosity Nano Eval Kit. This is a new eval kit from Microchip, and I standoff. Yeah, that's a good way to put it. So again, I just picked this up because STM32 is well supported by CircuitPython, and supporting boards not by Adafruit is interesting. And I go on DigiKey. I go on DigiKey and I look at the new products for the dev boards category and then sort by price. So it's all new products sorted by price, and then there's like I have a cutoff of like what is too expensive for me to just pick up as like make sure I have it for if I need it sort of thing. So let's just take a look at this. Because I think it's pretty new. I don't know if there was one thing I bought that they didn't even have a picture of the board yet. Hi, Gavin. And Eric. So let's just pull this out. I probably won't keep the box anyway because the boxes are just like take extra. Okay, so this is pin headers that was in here. I got tons of those. And let's open this. The Nano Eval Kit. It made December 3rd, 2019. So there you go. That's from Microchip. And it's pretty basic. Looks like it has a debug micro on it and then just the STM32 with all the pins broken out. They are castellated. Happy Friday, Mr. Certainly. Glad you could make it. And I can compare that against the Feather again. And I can also put, that's the Sala, the ESP32-S2. And I can look at the cost and look away if you don't want to know what else is in my box. It's in here somewhere. Yeah, see, it doesn't even have a picture. It's $15. $15 US. Yeah, it's kind of neat. I like the idea of the castellations. That's something I think we should consider. It is an ATSAMD G17D, I think, which means it has a little bit less RAM. Mr. Certainly asks, what's the difference between regular pins and the castellated pins? Yeah, so these are kind of regular pins, and they actually came installed with the headers here. Let me see. So these are like regular ones, and they're installed with headers. That's kind of the only way to use them. But what castellations are actually like you put a hole that gets plated, and then you cut it in half. So if you look actually on here, this module has castellated pads along its bottom edge, and then it's surface mounted onto this PCB. It's kind of hard to see, but castellations are a way. What are they doing? Okay, that's a motorbike. If they're doing if they're leaf blowing again, I'll have to shut the window. But yeah, castellations are great because it means that you can mount the PCB onto another PCB, making it nice and flush. And you can see here that this has nothing on the bottom. So yeah, castellations are the kind of cut holes on the side that allow you to connect electrically and kind of mechanically between two boards without any pins in between. Okay, and let me put that down in my pile. Oh, I think we're about done. So I've got, oh, my box is empty. 2 more. So first I've got another set of header pins, and these are the taller ones, so that like bit that is super thick is taller than the other pins. I'd go grab the other ones to compare, but they're on the floor and I'll close blind myself with my headphones if I do that. So yeah, I just got two full size of those. One thing I figured out is that it is slightly cheaper to get like full length, like the standard length of these. And so these are like 32 pins. And the way that I figured out what the standard length is, because on DigiKey, they'll cut them for you. But like the per pin count is slightly higher if they cut it. What I figured out is you could go on the data sheet for these. Unexpected Maker says, I want to see that. Do it, Scott. Okay, you want me to grab the other ones? Okay. I could take them out of the bag too. Or did you want me to close by it myself, which it turns out I didn't actually do because I had it unhooked. Okay. I'll take them out of the bag. They'll be easier to see. I could even go get the original ones too, but let's not do that. That's in another room. He wanted to see you close on yourself. Ah, well, too bad, so sad. Okay, so there's the two. Hopefully you can see them well enough. This one's not sitting flat. But the one on the right is not as tall as the one on the left. So I want to put together tall machine pins. Yep. Unexpected. Good job not doing it though. Hi, David. Okay, yeah, so the idea is that with the flip dip, it will sit high enough off the board that the flipped over dip pin, oh, I'm not going to put these in the right bag. Oh, well. Sit high enough that the PCB for the flip dip is not, so it's even. Okay, then we have one more thing. And I know that Mark already guessed it, but it's the Stm32 L4 P5G DK, so it's the Discovery Kit. I'll just take it out of the bag. Where is the consolidated chat stream? It's done by Restream.io, and I don't think that you're able to... I think it's only me that can respond to everybody. And I don't have the Discord in there, so I hope not everyone... I hope everyone's in the other chats. Oh. Yeah, it's basically... I'm seeing all of the different ones. Which part number? You want the tall machined pins? Okay, so I won't spoil it now. But yeah, they're Samtech parts right here. You can just copy that. Actually, you know, I could post it in the chat. All right. Okay, perfect timing. We're like half an hour in, and we're on the last thing here. So let me get it back so I can make sure you can see everything. My speaker's right there. Looks a little hard. So that works. So this is the L4P5. It's kind of like a less straightforward part number than most of the ST parts. This is the Discovery board. So basically the difference, the Nucleo boards are very kind of cost reduced, and they don't usually have a lot of extra things to go along with it. But let's see if we can't just pull up 32 L4 E5 Discovery. Oh, I guess I had it in. Yeah, they were expensive. Those header pins were like $4 a piece for 32. But I'm not making, like, I'm only making them for myself. And the other thing I did do is, the other option is actually the pins that get soldered in are like twice the height of a PCB. They stick out a lot. And so I actually created just a board to go under the main board, this flip spacer breakout. Yeah, so I made the breakout so I could basically stack two PCBs and kind of make that top PCB sit higher as well. So I'll try that too. I just haven't gotten my OshPark order yet, but maybe next week I'll unbox. It doesn't come in a box. My OshPark order it's at the fab now, so it might be here by next week. Okay, so the cool thing about Discovery boards is they usually have extra stuff on them as well. So I was going to pull it up. And I think the quickest way is just to find it here. Again, so it was $37. And it's so new, there's no photo or anything about it. So let's see if I can't. I don't know what it's called. Discovery kits. Product selector. L4P5DK. That's the one we want. Key features. It has a connector for a 64-bit color LCD with RGB. It has 4 gigabytes of eMMC. Now that's pretty interesting. I've never actually worked with eMMC, but my understanding is it's very similar to an SD card. It's just baked like into an IC. Footprint for a microphone. It's got a 512 megabit OctoSPI NOR flash memory with DDR mode. Eric asks if they fit in an SLBB. I don't know what an SLBB is. I would look at the Samtec stuff. Or, yeah, I'm not sure what that is. Mark asked if I've seen the 240 by 240 LCD for sale. I've not looked. Okay, 64 megabits OctoSpy PS RAM, which is PS RAM's a thing that we're going to start supporting, especially because the ESP32-S2, which we'll get to shortly, also has that on board. In fact, I'm curious to see what manufacturer of PS RAM it is, because I haven't found very many PS RAM chips on the interwebs. So I'm just kind of curious. I forget the name of the company. OctoSpy. I'd binge watch that series. Yeah, too bad I'm not a TV writer. Somebody else could do it. All right, let's just see if I can't read it. So there's a chip that is an NXIC. And then there's also an AP memory chip. So it must be one of those brands. Oh, interesting. This is like a rocker joystick, I think. A 4-direction joystick with a selection button. Huh. That's a weird part. I haven't seen that before. SWD 10-pin connector, which is awesome. Oh, interesting. So this small chip is the LP, or the L4P5. This is actually marked, I think it's micron. It's like the M with a, I doubt you can see it, and I can't see if you can see it, but it's an M with kind of a swirl around it. So, yeah, interesting. We're definitely getting, in the higher end microcontrollers, getting to a world where RAM is outside of the chip, and flash as well. The IMX RT has flash external. And that's the DigiKey unboxing. Was that everything you had hoped for? Unexpected Maker says Lion Tech are the main PSRAM player, it seems. I didn't see a WinBond. Oh, SLBB is a solderless breadboard. I think they fit in a breadboard, but I'm not actually sure. That's a good question. All right. Okay. Any questions before we move to the recap? Yanni asks, or says, I might need a wireless headset to ease the movement. Well, you know what? I do have a wireless headset. Let me hit my mic. The problem is that the reason that I use the wire is that it's coming from my microphone, and my microphone's piping my voice into my ears. These wireless ones don't work well. Yeah, Eric says the micron part might be the eMMC. That would be my guess too. Especially because it's like 4 gigabit. Is that what it was? 4 gigabyte. Yeah. It's rebranded Lion Tech. Yeah, that's what I was seeing, is there's only really one source for it. I think it'd be cool to have as a breakout. We've got FRAM already. All right. Well, I'll keep answering questions as they come in. Let me check the Discord. Yeah. I need to figure out how to get the Discord chat and the restream. Okay, let's switch to this one. Hey. Oh yeah, I should add the restream chat to that other view. Oops. To this view. I don't know where I'd put it. I could put it on the left, but anyway. Mr. certainly says try out open back headsets. They help a lot with being able to hear yourself talk. A wired Sennheiser, and love it. Yeah. I already have plenty of headphones. I don't think I need another pair. These ones are actually more comfortable than the wireless ones too. Like slightly. I switch back and forth. Okay, So let's talk ESP. Some of you, I think I've told about this already, but I'm still wrapping up this lower power PR. I thought, um, yeah, Carlos says, any recommendations on how to know all the memory type acronyms? Does PS stand for pseudostatic? That's my understanding. That doesn't mean I'm correct. But yeah, I think it's pseudostatic. Um, Unexpected Maker says, you already have plenty of dev boards too, but that didn't stop you from getting more. It's true. It's true. I mean, I have lots of headphones too. I have two sets of over the ear, wired and wireless, and then I have in ear, like on my desk, all tangled up. But I've got in ear, wired, and in eared wireless on my desk as well. So I've got plenty. Okay. Let me close this. My dev board habit is an artifact of me wanting CircuitPython running on everything, which means that I'm a good person to lead CircuitPython because I'd love to see it there. And we're getting more and more people with more and more interest on other platforms. Okay. So I guess I could show my OshPark stuff that's coming since it's open. Here's the flip dip. Here's a flip spacer, which is just another way to deal with the fact that the board's too low. Can't read the restream, but maybe it's just my resolution. Yeah, I didn't want it to take over the whole screen, although maybe I could have a thing for that. This is the Octal buffer breakout, which is the logic level translation sort of thing. .kami says more likely your resolution. This byte pull is it's a breadboard. It's a vertical board designed for the breadboard where one is a power pin and then it's connected to 8 resistors to pull up or down the other 8 other lines. And then this is a breakout, again, a vertical one. It's pretty tall, a pretty long vertical one for serial in to parallel out the shift register. And again, if you want me to share these, just bug me on Discord and I'll share it and send you the link. Okay. Let's see. Where am I? So I've been struggling with this lower power change that is really just so hard. It's trying to like change the way that we keep track of time in CircuitPython from using the CPU clock to using the real-time clock. And the reason to do that is because you can turn off the CPU while the real-time clock still runs because they're typically in different power domains, which means you can save a lot of power. And in CircuitPython, we started with the CPU clock because it had a free timer by using the SysTick timer. But now we want to be able to shut the CPU down to start being able to do some lower power stuff. And so I had to do this big change across all of our existing ports to make that work. And I'm also trying to actually do a light sleep when you do time.sleep. And there are just so many core mechanics to that, like making sure that USB is working, that it's just been a whack-a-mole of bugs for weeks now. And I said in our internal meeting, I was like, I'm so sick of this PR, but I thought I had it. I fixed STM on Tuesday. Like my weeks tend to be like pretty busy Mondays, don't get a lot of programming in. Tuesdays, I can usually get a lot of programming in. Wednesdays, before all the shows, I can. And then Thursday, Friday, now Friday is also streaming, but it's tough. Like if I spend the first half of my week trying to get the lower power stuff done, I end up only having like one solid day of work, like Thursdays plus some on Friday to do the other ESP stuff. So I'm really looking forward to getting the lower power stuff checked in because it's a building block for everyone else to make the lower power stuff better. It's just I thought it was ready. I fixed STM on Tuesday. I sent it out. Dan started testing it, and he realized that the USB on the SAMD21 is flaky, so it works sometimes. And flaky bugs are the worst bugs because they're really hard to pin down what the reason is. So I looked at it some last night, and I'll tackle it again next week. But I don't know. I don't know what the error is. I don't know what's causing it. And so until I get that off my plate, it's going to be this ESP32-S2 stuff is going to be kind of piecemeal. Yeah. But the good news is that I had some solid time yesterday, and I feel like I made lots of progress. So where did we leave off last time? Let's kind of like think back. What I think we left off at was we were starting to hack the make file, and we were kind of seeing what includes we were missing, adding the include to the list, and kind of going through that. So I've made I think I've made it kind of through that process. I'm no longer getting include failures. So let's just dive deep, as in the deep dive. All right, I'm going to close all this other stuff and reopen as I need it, and holler at me in the chat. Eric says, since you're not accomplishing much, you should become a manager. Well, yeah. I mean, we're kind of a scrappy open source project. I mean, a lot of us are paid, but to some degree, I'm there. Like, I also spend a lot of time doing reviews and stuff. But the benefit of doing that is like, then other people are doing great work, and I don't want to block them. I want to see like the only way that an open source project scales is if more than one person can work on it. So we're not going to give up reviews, and we're working on getting better at sharing that load. But yeah, kind of managery stuff. Okay. What was I going to open? I was actually just fixing something else, so I've got other folders open. Let's open the make file. Maybe I should show it as a diff, but that might be clearer. This is the IDF, that's why it doesn't have a make file. Okay. So here's our make file. This is all boilerplate. What we were modifying, I think we modified the cross compile last week, and we were adding all of these because we were finding includes that we didn't have. This one is different than what it was last week. I actually wanted to make sure that when we generate, like the very first step of the build process is to create a directory where all the build artifacts go, because we want to keep them separate from our source code so it doesn't clutter up all of our source code. So what I made it do is we standardize on like build dash the board name as the top level build directory, and then I also wanted to create a subdirectory of that for all of the build stuff for the ESP IDF. So the plan that Ivan suggested when we read over the chat that I had with Ivan, so I finally got to it. But the idea is that we use the existing build infrastructure as much as we can for the ESP IDF to basically build libraries of the components, and then we'll build MicroPython or CircuitPython. We have the same system, basically the same build system still. Kind of. We've reorganized some stuff, but they're both make files. So the idea is that we'll build CircuitPython separately, and then we'll build the ESP components separately, and then we'll only link them together at the very end. Now that's almost true, but the one thing that we were running into last time is that when we include files that end up back into the ESP IDF, we actually do import some of their header files. So we don't include their source code, but we do include their header files. And when those header files are included, they get checked with the compiler warnings that we normally compile CircuitPython with, which I believe we are stricter than MicroPython as well. in terms of what our compile checks are. The two that I ran into yesterday, one is the, I can show the changes that I made to the IDF as well, but there's two. There's one called undef, which is a warning that says, hey, you did a pound if this preprocessor variable, and it's not actually defined in this context. And they warn you that says, by default, we set that value to 0. Electric Snake, we're in the weeds talking about build systems for CircuitPython. Lost my train of thought. Right, so undef warns that a preprocessor macro is not defined when you're doing a macro condition as if it should always be defined. And the fix for that, and I should pull up. I have now my own copy of the ESP32-IDF, which I actually did a pull request already to Espressif for. Found a bug in my thinking as well. So my editor just automatically deletes trailing white space, so it's kind of like a happenstance thing. But here you can see that I had to change this pound if to a pound if defined. That's what the check is making sure. And that's common. Like, this is totally an okay change because the way that these config things are defined, and this is what I had to add here. So boilerplate, boilerplate, boilerplate for building CircuitPython. And then this bit is the bit that I added kind of down through this line is what I added to this file to build the ESP IDF from a make command for CircuitPython. So the first thing I had to do is make the new directory. Yeah, Mark says you can also ignore the diagnostic, but I'd rather just fix it. We do that for some hals where we'll ignore it temporarily. But yeah, I'd rather just fix it. And I'm okay like linking to my copy of the ESP IDF temporarily. Okay, so the first thing that we do is we construct the subdirectory, the ESP IDF. These $@, these are makefile magic that fill in, that are variables where $@ is equivalent to this. That's one I know. The next thing that we want to do is we want to build an sdkconfig.h file based on the kconfig. So, yeah, kconfig. Okay, I'm in the wrong directory. Let me show you what that is. So I think this system originated from the Linux kernel. Somebody can correct me if I'm wrong, but there's a system where it has this like menu. Here we go. It gives you this menu for what all the configuration settings that you want. So this is something that Linux kernel folks understand, and therefore they propagate into other projects that are related. So it's in the ESP IDF that they use this, so you can configure like different flash speeds and flash sizes and modes and all that. Zephyr uses it as well for defining like choosing options and things. I'm not a huge fan, but I haven't used it from very much. Anton says I'm right. Great. So what you can do is you can edit that file, and then when you're done with menu config, it will write it back out. And right now I have it writing, it writes it into an SDK config file. So there's no extension on it. And I actually have, what I figured out how to do is have it write back to the particular board's SDK config. Now this is actually something I want to change that I talked with Ivan about today. So yeah, in the future maybe I will, but for now I don't want to do that. But basically, my goal for the SD config, K config in the boards directory is that they'll be as short as possible and only have the stuff that pertain to the board itself. And then we'll have a defaults file in the top level of the port. So we'll have an SDK config .defaults that has basically everything that is shared amongst all of the boards, which should be good. And that I don't know. I haven't dug into it too much, but that's my thinking. Yes. So going back through here, in order to make menu config creates SDK config, and then we need to get SDK config in a form that we can include into our C code, and that's done through a .h file here. So if you don't know make files, good for you. They're kind of a pain, but I can explain it here. So this first thing is called the target. I don't know. It's the output. I think it's called target as well. But basically, this is the thing that you end up with after the stuff below this runs. And then the stuff on the right-hand side are the things that have to be made before we can make the target. The first thing here is that we need, it depends on, so you can think of these as dependencies. It depends on SDK config in board. And so if this file changes, it will rebuild this and anything that depends on that downstream. And then if you do a pipe and then something, that's called I think it's an order only dependency, meaning it doesn't care if it's up to date. Thank you, Mark. It says I'm correct again. I'm on a roll. My brain's with me more than it was last week, which is good. This is a build only dependency. So it just means that this thing will have to be built and exist before this command is run. If this thing changes, it doesn't cause you to rerun everything else, which was a problem I had yesterday because it runs in parallel, and I ended up running this cmake command multiple times all at once, and it was like not happy at all. So I'll scroll through this. This changes us to that subdirectory for the IDF build, and then we run cmake, and cmake is what is called a meta build tool, turns out. I think we talked about this last week as well, but it basically takes cmake files and generates Ninja files in this case. I think it's at the end of this. Yeah, so this at the end tells it to output Ninja files. And then Ninja actually keeps track of like what needs to be built when. Going in reverse, I figured out that I saw, oh, come on. I think there's a way to wrap. There we go. Okay, so I saw there was a way to set the target, but the example I saw didn't have this IDF underscore. And so I realized I needed it based on the cmake files. And so now I'm actually building for the ESP32-S2, which is great. Toolchain file is something I think I need. And then this SDK config define tells us where it's actually both reading from that location and writing to it, which is a little funny. So this is where menu config gets which thing it should output to. And then I think the -s is the source directory and the -b is the build directory. So we're already in the build directory, and we want 2 levels up for the source directory, which is where the cmake lists file is. So when we're done with this, we have our headers and like the process that we were going through last week of making sure that all of the Summersoft says CI is going to be full of writes in the future. Mark asks, could you not use the cmake Unix makefiles generator instead of Ninja? I believe so, but I also believe that the new version of the IDF is using Ninja explicitly, so I'd rather just do that. That, and I like Ninja more. Ninja has a lot less magic, and that's why I'm interested in it. Like, there's some. If we go down to this next one, perfect. There's this weird percent magic that Makefiles can do. So this is like a pattern match. So it has a process for, oh, something depends on this value. Let me look and see if any of the patterned rules match it. And so that's what this is doing, is it's saying this is how you create any .a file within these dually nested ESP IDF folders. It turns out the build itself, like all the build files for the IDF, have an ESP IDF subdirectory as well. Hey, Ivan, thanks for the help. Ivan was helping me earlier. Okay, so, and then I just wanted those to depend on the K config. So as of now, these build rules will not help you if you're actually editing ESP IDF, because it won't be able to tell that you change those files because it doesn't realize that they're like interconnected. And the way that we're building it is that I have it building is that we're just changing to the ESP IDF directory, and then we're just calling the Ninja rule directly. And this magic, the $*, is Makefile magic for the portion of the pattern that matches this percent. This is why I like the notion of a two-step process, where you can have a thing like CMake or Meson or custom Python code that figures out all of these .a's ahead of time and generates Ninja files that just match it. Like, I like that idea better. So yeah, this is the rule that will make our .a's for us, which then will link into the CircuitPython binary. Here's how we run menu config. And the nice thing is that we've baked the board into the configuration up here when we ran CMake. So, we're in a board specific build file, and we've built the IDF specific to the board. And so when we run menu config, it saves it back to the board specific place. And I want to evolve this a little bit because I want the SDK. Yeah. Eric says the make dependency rules could link into the IDF files. It's true. But the alternative, well, all of the dependency stuff is done for what am I thinking? All of the dependency stuff for the ESP IDF is done in CMake. Now we could do it as a like sub make file, but make files aren't great at being included into each other. Although we do use that in CircuitPython. It's gross. I'm actually more interested in moving CircuitPython away from make files and into a world where we do, I think, ideally Python files that generate Ninja. And then we could sub Ninja the ESP IDF and do it that way. Yeah. And there's like a Ninja rule that reruns CMake, which I ran into, which is interesting. Pretty wild. Okay, so that's cool. Like, that was one of my goals, is that we could run menu config for a particular board. So I was happy that that got to work. And then this thing is more Makefile magic, where it's saying for this target, the queue I last, we add an order dependency on the SDK config. And the reason that we do that is that queue strings are intern strings. Did we talk about this last week? But basically, MicroPython and therefore CircuitPython will go through all of the C files, and it will find all of the strings that are called MP _ Q string _. And it collects them all up, it deduplicates them, assigns every string a number, and then squishes all the strings into what they call Q string pools. And the way that it does that is it basically sucks all the C source up, it runs the preprocessor, and then analyzes those files. And the preprocessor is the thing that does includes, And so we need to make sure that this SDK config thing is ready and set up for us to include it. It's crazy. And that's where I'm stuck right now with my like custom Ninja stuff, is just getting the keystring build rules, which is also why I don't feel like I think CircuitPython has enough weird build logic that it's probably best served by just using a language we know to define all of those rules, Python. So Python would generate Ninja, and Ninja handles all the build stuff, I think is where I've ended up. And I've tried to ask some folks, and maybe Ivan can tell me, no, CMake's great. But that's kind of what I feel is going to be easiest for us. Okay. And then I had these two things. This is which IDF components do we care about? And I was really happy that there's standard .a naming. So we want the sock, the driver, and the log. The last two we needed for tiny USB. And then for each component in this list. So this is more, again, like this is code, like this is logic that we could put in Python. It doesn't, there's no reason that we actually need to use a makefile for this, which is just why I'm ready to move off makefiles. I'd rather have my logic I was looking at CMake and trying to say, like, it seems like that's the popular thing, and I need to find it again. But there was this big, I think it must have been like a presentation I watched that said, CMake is code, treat it like code. And I'm like, if it's code, why aren't I just using something that's simpler, that I already know how to use? I know already how to do logic in. Like, if it's just generating Ninja files, I can do that from a Python file just fine. Prove me wrong. Okay, so here's an example of things that I would like to do in Python, but now I'm doing in crazy makefile world. So for each thing in the second argument, call it the first argument and put it in the third argument. So for this component is sock, produce this string, so ESP-IDF, ESP-IDF, sock, libsock.a, and then for driver and log as well. And then we do the same thing for includes. So for header stuff, we do that as well. And lastly, we tie, again, I was talking about this earlier, we tie all of the objects that we built for CircuitPython with the .a's for IDF, and we link them all together. And this is perfect. At this point, what we should be able to do is run the linker, and the linker, so there's kind of like 2 stages or 3 stages of errors that you'll get. What we were dealing with last time was the first stage, which is include errors. So that's all of the stuff that the preprocessor is doing. It's doing substitutions, it's doing the pound if logic, which is like another weird logic language for templating, basically. The second stage is actual compile errors. So it will warn you, like, one of the IDF things I found was like, we have a check that does sign compare. So it will warn you if you're comparing a signed integer versus an unsigned integer, for example. You want to make sure those two things are the same. Mark agrees with me. I could agree with you, Scott. CircuitPython would benefit from having Python-generated Ninja files. And Ivan says, oh, linker groups. Yeah. I actually, you should listen to embedded.fm. They had a call for like listener questions for their podcast this week. And I had a big brain dump about a lot of this stuff, actually. And they answered, like, they talked about it a little bit on there as well. So I recommend you listen to it. When they say Scott asked this, that's me. I was excited to listen to that earlier. And one of the things was like, how do you deal with a system that builds things like that? And they said, well, we don't really... Eric, I don't think that's a fair thing to say. Saying, sounds like you want a new tool because you don't want to learn Make. Like, I clearly know Make. Like, I've worked on Make in CircuitPython for 4 years now. To say that I don't want to learn it is not quite fair. I guess you could say I don't want other people to have to learn it. I think that's more fair. I think makefiles are great for simple things, and in fact, I was thinking about having a makefile that would call my Python script that would call Ninja. But like for all this logic stuff, like I don't think it's the right tool. I think there are better tools. Okay, so I was talking about. I got distracted by folks agreeing with me. Uh, Three stages of errors: preprocessor, compiler, and linker. The compiler will warn you about like stuff on an individual .c file basis, and then David says makefiles are great unless you have to maintain them. And Mark agrees with me that having a makefile as an entry to building and calling the Py to Ninja stuff would be cool. So we're on the same page. And the third stage is linking. Now, linking is the process where one function from. So at the end of the compilation stage, you have a bunch of independent files that have different functions and state that each of them need. And then the linker basically figures out how all of those things fit together. And for things like pointers, we'll actually figure out the values of those pointers, right? Pointers are memory addresses. And so what you'll do is you'll the errors that you'll see come from the linker will be things like you referred to this function in this file and we can't find what you're talking about, right? And it will say undefined function. The other thing that you might see is like, oh, we found two of this function. That's also bad. Like, which one do you want? And so this is the point that I think we're at. Secret is, I know that we're not quite at that point, but that's where I was hoping that we would be, because what I was hoping we would be at is this point where like, oh, we can't find app.main or something, and we move. Like 2 weeks ago or 3 weeks ago, I talked about like what the challenges would be. The build system is one. Like I feel like we're almost to the point where we've figured out the build system. The next thing that we talked about was like we had two other things. We had memory layout stuff and we had free RTOS. And I think that the free RTOS thing is like we're on the cusp of turning from build system to free RTOS. Because what we'll find is that like we're not providing things that FreeRTOS expects us to have, and we'll see. I don't know what those weeds will bring. Hopefully next week, like we'll be in those weeds. And again, I'm gonna try to work before the stream next week so that we'll do kind of the same kind of catch up overview, which I think is actually a better way to do it. Eric says, the chat lag is too long. I'll shut up. Timon says, thanks for not wanting me to suffer through makefiles. Bruce says, I'm great at using makefiles. That's about it. Anton says, I like CMake, but might be just gotten used to the tool. It can be a bit more user-friendly, I suppose. Yeah. And then Greg Wire asks, are there any good books or tutorials on free RTOS? So I'll leave that last question out to other folks because I don't really know FreeRTOS. I haven't gone up that learning curve yet, and we'll see that in coming weeks because I'm definitely going to get into those weeds. But if you have recommendations, drop them in the chat, and I'll read those off and may actually look at them myself. One thing I did look into for FreeRTOS, since I'm on a tangent, is that I was looking at all of the API names, and I was like, there's this weird prefix, and I don't understand what it was. So I finally found their style guide, and they prefix all of the function names with like a character that indicates what the return type is, which I thought was really interesting. I've not actually seen that. Okay, so we should get errors about missing functions or duplicate functions, but when I run it, and you can see that, let's see what happens. So this is CMake being run again, which I'm not. I guess I ran makefile the menu config, so that's probably why. Q strings decided not to be updated, and here we go. Fatal error: LD terminated with signal 11. So I'm actually crashing the linker, which should never happen. Eric says FreeRTOS sells their docs for income, but I don't know about learning materials. Yeah, I don't... Like, I think the freertos.org site has some getting started. The problem is like, at least for me, I'm not getting started, right? Like, I'm more like, how do I integrate stuff into other stuff? which is one of the unique challenges of CircuitPython and MicroPython too. But I also do have a good example because the thing that I'm going to look at when I'm starting to do this work, yeah, Ivan, you're ahead of me. Ivan wants to figure out why it's crashing so we can fix it. What was I going to say? TinyUSB has support for multiple RTOSes under the hood. So yeah, I'm going to copy the way TinyUSB does things, I think. All right. Mark and Ivan really want me to get the verbose output. So the idea here is that the make command is pretty slow. And if we can just get the individual linking command, we can iterate on the different pieces and tweaking that until we can figure out how to make it not crash. So let's do that. And the way that we have it set up in CircuitPython, so this v = 2 is not a generic makefile thing. It's a, I don't believe, correct me if I'm wrong, but it's at least a MicroPython/CircuitPython thing. So if we do v2, it should spit out all of the commands along with its output. One thing I noticed, and I think Ninja does this better, is that I think that I saw in their comparison between Ninja and Make is that Make will interlace the output of commands where I'll make it taller. They're trying to get ahead of me, which is totally cool. And I'm off the page. There's a lot of .o files. What I'm going to do is snag it here. So that's the full command. And you know what? If you want to look at it, fancy. I guess you can't run this. I guess that's not not as useful as I was thinking because you don't have all these artifacts. Although my GitHub repo is up to date. Oh, I copied the gist. I don't actually know the... I'm not like a find replace person and... Don't copy the entire command. I didn't crash it. I don't know. For some reason I can't do the like proper replace. Maybe the regular expression one will do it. There we go. That looks right. Boom. All right, let's analyze this. Because this is why I'm okay calling it deep dives. Let's look at linker commands. Okay, so the first thing we're going to do is we're actually calling GCC. And GCC knows how to call LD. And the reason that we switched to doing through GCC is that some of our builds do a LTO process, which is link time optimization, where if like one function's really small, it'll actually smush it into another. Ivan says, what looks odd is that you have all the D flags to the linker. True. I think that's because we put the D flags in our C flags. Eric says that an outside chance of getting around the linker crash would be to either make clean or make clobber. Yeah, I can make clean it. It shouldn't take too long. It's not, I don't believe it'll work. But I made it so that it does actually work. Or I think it'll work. So we'll let that go. Okay, so yeah, it's a little weird that we're doing all these defines because as we... Oh! Am I dropping frames because I'm compiling? We should have thought about that. Actually, you know what I can do is I can yank the overhead and we can see if that gets me back some CPU. Hopefully that won't crash things. Am I live still? Can y'all see? All right, let's scroll down. And this also is probably not the cause of the crash, but your linker group only surrounds LGCC and LC. Yeah. So -Ds are all preprocessor defines. O.S is the optimization level. -G GDB3 includes debug symbols. -Is are locations of include files, which again we shouldn't need here, but we have them. And this is like I copied it from another port, so we know that it like should be okay. We turn on all our error messages. We say we're GNU 11, so this is like a, you can think of this as a version number. We have no standard lib, which maybe we don't want. These are functions. These are -W are errors. Another define. This has the -F. These are like features that are enabled in the compiler, and function sections and data sections means that they're kind of managed independently, because we can then do GC sections, which tells the linker, hey, anything we don't actually use, you don't need to include, which makes for a smaller file size. We've got pound defines for tiny USB to tell it we're an ESP32-S2 with free RTOS and buffer sizes. We've got a second no standard lib. Yeah, this stuff is not managed well, right? This is all makefile output. We say our specs are nano specs, which I don't know is not, may or may not be right. We have another GC section. These are linker scripts. I think these are correct. I stole these out of the command for the IDF, which actually is what I think my next step will be, unless y'all have suggestions. And then this last bit is just going to be all the different object files and the .a, the last three IDF.a's are at the end. And then this group is the like system level libraries that we're linking against as well. So yeah, I think the next thing I want to do, let's see, we've got about 40 minutes. So if you've got ideas, let me know and I'd love to try them. There's kind of two approaches I can think of. One, we can try to reduce the full command and okay, I'm gonna do what Ivan wants me to do. I mean, CircuitPython's not gonna work anyway, so we don't need to link it. But yeah, so one approach is to take this giant command and remove stuff to see if the linker stops crashing. So I'm just gonna have a copy here that is there and to here, and I'll copy it and I'll run it again. And it worked. Eric wants to know which chat has the least latency to the host. It's a good question. It also probably is impacted by the latency between my stream and you seeing the video too, since it's round trip. Okay, so that looks like it worked. Build solo firmware. So it didn't crash. We have a file. I guess I didn't look at the output, but I think my terminal would show it. Oh, it's off the screen. I think I would see if it was a negative negative thing. Okay, so I have a feeling the next thing will be to bisect it. Like maybe we just include, like maybe we're building them in the wrong. Like maybe we're building all our .os as ARM. Something crazy like that. Or RISC-V because I don't want to say that. So this is the same thing, but with one. Yeah, I should make sure. Yeah, my Discord's not actively. Yeah. All right, I want to actually run the full command and see what happens with the crash. Yeah, okay, so we will see it there. So it worked okay. This has the one MP state.o and it worked okay. So if we have a single object file that's causing it to crash, I can literally like fake bisect it to figure it out. So let's just do here's the start MP state. Let's just go from here to here. I don't need to save it. Why is that my like automatic thing I do? Paste it. Okay, so that failed as well. I mean, this is kind of suspicious that we have ASM arm.o in here and emit arm, but we also have emit extensa. So like maybe something's messed up with what we're doing. Okay, so we can delete. Let's just delete half again. And I'm just doing a coarse half. All right, that's segfault to 2. Good, we're whittling it down. So let's take half of that. So basically what I'll do is I'll wait till I have... Oh, it could be the extensa stuff. Because I think it's a different extensa chip. Ugh, I hit Control Save again. Yeah, cleaning is always a good first step. Okay, that's still bad. We're getting it down. So basically I'll Control Z it. Oh! Hold on. Kitty's having a seizure. All right, I'm back. Yeah, so I mentioned it at the start, and I'm glad I did. But I have two cats. They're both white. They both really look similar. But the boy, his name is Spook, and he turned 6 in June. They're brother and sister, so they both turned 6 in June. But he had the first seizure I saw. He's epileptic. The first seizure that I saw him have was almost 5 years ago. It was like the week after I quit my job at Google, and I was like, like taking care of this cat that I didn't expect to like as a, as an expense. But I'm in tech; it's not a huge thing. He's on meds, but he still has seizures, and they usually. I don't really want to show him on stream, but he starts by hissing and he gets a little contorted, and then occasionally what he'll do is he'll like spin in a circle. And the reason that I want to like focus and watch him is just there's tons of chords in here, and I just don't want him to get all hung up on a chord. So watch that, and then he's fine. And like he's been having them for 4 or 5 years now, so it's kind of how it goes. He did have a kitty MRI, and they didn't find anything. So at this point, they're just puts him on drugs that make his brain slow down, which should ideally reduce the severity of the seizures, which it definitely does. So it's not usually classic like jerking like you think of a seizure, but growling and hissing and like unresponsive all through that too. All right, well, I've kicked him out. My wife's gonna go give him treats, I think. And let's continue where we left off. And I did unmute. You can all hear me, right? Let me just, before I go too far, let's make sure. I saw a ghost from Mark Olson. Everything is still running. Mr. Certainly says loud and clear. Awesome. Well, thank you so much for your patience. Had to watch the kitty, make sure he didn't do anything too crazy. Okay, so we were whittling this down, and somebody had an idea, I think Mark said we could see information about the file and the build types. Let's just do that. Although he's trying it. Okay, so it says it's a 32-bit ELF, a relocatable, which means that I think basically it hasn't been linked yet. It's not stripped, and it's for the extensor architecture, which all seems reasonable to me. So let's keep doing what we were doing. So let's just rerun this. And what we were doing is we were trying to whittle down. What we found is that if we included just the first CircuitPython.o file, it worked just fine. And but then if we included everything, it crashed. And so what we're doing is we're basically deleting half of the list of .o files from CircuitPython until hopefully it won't crash anymore. And that will let us kind of seek in on the file that's the problem, which as I'm looking through this, I see, okay, you can see what I'm seeing. So these NLR files, I think have assembly code in them. So it might be that there's assembly code that is invalid for the new extensor core that the S2 has. So let's just try that. So I'm going to delete there, and I'm not saving this. I'm just copying it. Mark's going to probably fix it because he's pulling it all down. But okay, so we're still crashing. We don't have that many. Like this MP state one we know is okay. So we are whittling it down to the NLR stuff, which is actually, the closer we get to figuring that out, I think the more likely it is. So if we just... let's do it to this. Okay, so we segfaulted again. Let's just delete those 1, 2, 3 files. I bet the other ones... I had to Control save again. Had to install some stuff. Yeah, I'm suspect. I'm hoping Ivan's still around and he'll just be able to tell me what the assembly is. Oh, it still failed. Even though I deleted the NLR. Weird. Okay. We only have 3 files. So let's delete the x86 one. Okay. I think it's gotta be this pi NLRO. And I guess we can we confirmed previously the MP state was okay, so let's delete that and just leave the NLRO. Okay. So it still fails. So that's our problem. And let's just do our diligence. Yes, it's not in the IDF. It's in. So Mark asks, can't find the extensa GCC. Is it in the IDF? I don't think it's technically in the IDF, but when you get the IDF, you call install, and install will download it for you, I believe. So like, yeah, in the IDF, there's like install.sh, and that will download it. Okay, so it does look like the NLR pi NLRO is wrong. And it's late for Ivan, so he might have gone to bed. Okay, so that is the problem. Let's pull up the file. Unexpected Maker says it's in a hidden folder on Mac. In the IDF? Like if you git clone the IDF, you get the GCC? Because I thought I saw it downloading it. Yeah, there's usually with the IDF, there's 2 steps. There's install and then export scripts that you run to get, because it does like Python install stuff. Right. So install usually installs it. This is what I messed up. It installs it outside in like a dot. Ivan was telling me this because I did it wrong. There's the fish versions of install and export are not quite correct. They expect you to have IDF path and IDF path tools set, and I set that to the wrong thing and installed it in the tools directory because that's what I thought I needed. But the IDF path tools thing is actually where you should just where it installs the tooling, like GCC. So yeah, take a look at that. Let's look at this file and see if we can't see. You know, we could start actually just deleting stuff too. Oh, so this looks suspect. So what I'm seeing, and I guess I shouldn't drag it wider so I can see it because you can't see it. I'll do it right here. But this is MicroPython magic I still don't fully understand. It has to do with the way that the C stack is used also for the Python function call stack. And NLR is kind of like how it unwinds that when an exception happens. That's like kind of all I understand. But here we can see that it's doing certain things depending on what architecture it is. So we want, oh, that's it. So I expected to see something having to do with extensa in here. But there isn't anything. There's just 2 C functions. And the extensa thing is here. Which I wonder if I just cheat and comment out all the assembly. Or am I even setting this correctly? I might not be setting this correctly. How do I know? Where does this come from? Oh, it's not in there. It's in pi NLR to H. Yeah, Greg asks, do you have defined set for extents on x86? Yeah, I mean, I think the reason x86 is showing up as an object is that we're not, the build system that we have right now is not smart enough to not include that. But yes, I may not have the right thing here, although this actually looks right. So it looks like it's actually getting it from the compiler, which seems reasonable. And in fact, what we could do to make sure that this is happening is we could just say error. It works. And then that should tell us that we're getting in there. And Mark says, by the way, thanks for introducing me to AG, even though you didn't know you did. Yeah, it's kind of hard to find how to install it, but AG is also known as the Silver Searcher. Yeah, you hear the sirens. I don't know what the sirens are for. There was one day where there were sirens and they just kept going, and it turned out to be that, like, there's a... So I'm, like, this is south for me. There is a... And there's, like, a bunch of shops and restaurants and stuff. There was a big fire one day where all the smoke was blowing up, and, like, 5 businesses were burned out and stuff. It was bad. Lots of sirens. They just stayed. But, yeah. Okay, so I was just going to see to make sure that we're getting in there by just rerunning. I have to actually run the whole make. And I might need to clean, like Eric was saying. But no, it didn't. It didn't crash. That's suspect, actually. Then auto detects the machine architecture. Let's just put an error here and make sure that it crashes. That, like, our build system's picking up that it, yeah. So that's what I expected. And so we can just move this in. NLR extensa code looks odd. It seems to be written in extensa call 0 ABI, which is used in the ESP8266. ESP32 and ESP30S2 use a different ABI, so it should not be included into the build. Okay, yeah, that sounds plausible. The question, the weird thing is that like MicroPython has ESP32 support, so we could see what they did. I don't think Jim's watching. It shouldn't crash the linker though. Yeah, totally. I've always managed to find stuff like that. Like, you know, an error message would be nice. Okay, so we're not getting in here at all. So NLR set jump is not used. Set jump is not used. So that's not used. This PyStack stuff I don't think we're using. I don't know. Looks like we don't need that. And it is weird that the linker is being crashed by a file that is pretty standard. Let's make sure, let's do the same trick and make sure we're not ending up here. Even though we shouldn't be. Okay, so we're not ending up in there, which means we should be in here. No. Not in there either. And let's just do the same check of making sure we error. Ha, nice. Mark's got everything installed and is also crashing in the same way. Yay, it's not just me. Unterminated if. Ooh, I messed it up. Yep, I accidentally deleted an end if. Oh, I know I moved it. But yeah, I achieved the same thing I wanted to. I wonder if it's an alignment thing. So let's just comment this out and see if it works. Nope, still segvaulted. Comment this out. And it's still segfaulted. Huh. Deep dives means that we deal with the hard stuff. So the question is something is ending up in this file. It could be through did we decide that we ended up here? I think. The other thing we can do is obj jump, which I think obj jump is what we want. We can get an idea about what is in that file that is causing us all the trouble, which is, if I remember, not this file, but I'll just copy. It's pi nlr.o. And I don't want to disassemble, but X all headers. Lots of debug stuff. And then just the push tail and pop. Which now do nothing. I mean, I could comment the full function out, and then we should get an actual linker error. But no, we still segfault. Oh, you know what? Let me make sure that the segfault is actually caused by that single file. Which it's not. That is extra weird. Okay, so let's rewind a step or two. So let's have those functions there. We have to run make because this does the compile step, and then we'll rerun. So we're segfaulting, but let's see if we segfault when we just provide that. Okay, we don't. So now let's uncomment this. Time to check the compilation flags for nlr.o. Can you echo the results to get. I assume you want the result when it crashes. So let's get it to crash again. So make, and we actually do v2. So here's your answer for the compilation flags for NLRO. Which I think are the same flags that we had, that we looked through for the linking stage. I don't think they're any different. Do you want me to throw those in a gist as well? Or I could put them in the same one. Do I have it open? Oh. One big long string. Alejandro says Zoxbox is the best product from Adafruit. Thank you. You're welcome. I had nothing to do with it, but it looks pretty cool. And yeah, let's get it to crash again, but let's do it directly. And then we'll echo $? Right? And fish use status. That's one thing I love about fish, is that you do bash things and it's like, sorry, that's not the way we do it, but here's the way we do it. I'm pretty happy with fish. All right, well, it's 3:57, which means we're just about at our 2-hour mark. I want to keep going on just a little bit more, but if anybody has final questions, how about you post them and we can talk about whatever. I may not figure this out today, and that's totally fine. So let's just comment that out. Or did I do that one already? So Suavek, that was a 1 to answer your question of what the error code for the linker is. Okay, so that still doesn't work. What if I... Mark's also looking. Yeah. I'm totally okay, Mark, if you figure it out before I do. Okay, so that crashed as well. And that crashed as well. I wonder what this MP state thread is. I wonder if it's related to that. Can I do... It's kind of intertwined into everything. But I wonder if I could just cheat. Like that. Still... Well, that seg faulted. This doesn't seg fault. I keep forgetting that. Okay, so that's the MP state thread seems to be our problem. Does that make sense? Yeah, because the way that we whittled it down, we just whittled it down to one file that caused the problem. And if we fix that and then include everything else, if MP state thread is a problem, then the other files that use it would also cause a problem. I think we could do this. What is it? I think that'll work. No, it didn't. It didn't fill it in for me like I thought it would. I'm confusing my how to, oh, it's a different tab. Oh no, did I delete the tab? No. And you can't see it either. I'm sorry. Holler at me in the chat if I'm working off screen. I've got a big screen and I've got the like top left corner as the screen that you can see. So what I'm trying to do is trying to get it to print out what MP state thread is. I don't remember how to do that. Anybody have any ideas? Anybody know how to do it? That's the better question. Print out. Preprocessor variable. Ah, this has it in Summersoft says, in Pi I'm seeing it as mostly stack related. Yeah. What happens if I put this in? It still doesn't work. I mean, I could make it a warning, but then I may not see it as it scrolls by. Or we mark it as an error and it's fine. Oh, I guess that's not the right answer. Oh, yeah, this thing. This terrible hack. Programming is just taking stuff off Stack Overflow, right? All right, we're just about done. Hang in there, everyone. It's Friday afternoon / really late in the evening for some of you in Europe. Okay. It still didn't work. I'm expecting MP state thread to be replaced by what it is. Pragma message, MP state thread. Stack Overflow failed me. Probably support it too. Equals. Yeah, what the heck? I wonder, maybe it's not defined? Oh, so Ivan says, I will try to figure out this linker issue as soon as I figure out how to solve the make message format no such file or directory. We just found that issue. And by we, I mean other smart folks on our Discord. Just merged a PR for that. It is... I thought it was a PR. Is it open? Have we not merged it yet? Oh wait, no, I'm staring at it. Adjust for change in brew. Yeah, you install it, but you also have to set the right path, like the path moved. Yeah, Jeff was the author. There's this new set environment thing. I think they moved its location or like changed it so it didn't set the path right. But yeah, that's totally something that just happened. Thank you. I appreciate you looking into this and all your help. It's been really great. Okay, Summersoft's linking me to something. All right, this is what it would be. But the thing is that I don't think we have. Do we have MicroPythread active? I don't think we do. That's one of the things that MicroPython does that we don't do. Thread. I think we have it turned off. Yeah, we have it turned off. So that means that we're in the second case, where it's just np state context.thread something, which makes no sense to me why it would crash the linker. All right, we're over time. I've run out of ideas, and there's other smart people who want to figure this out. One of the secrets of why I like to stream is it gets all of these like early issues in front of you all. First and foremost, thank you to everyone who's helping me on the stream. I really appreciate it. If you help me off stream, of course, I appreciate that too. If you want to hang out with me and lots of the other folks that are in the chat, I encourage you to join the Adafruit Discord server, which you can join at adafru.it/discord. We chat there. We have a weekly voice meeting on Monday mornings at 11 a.m. Pacific, 2 p.m. Eastern. So if you like this long form hearing from everybody, well, this is just hearing from me, but in other cases, our meeting on Monday is everybody's welcome to join and let us know what they're working on. That can give you a broad view of everything that's happening in CircuitPython. This stream is the narrow view of like just what I'm working on. I'm going to keep doing this, I think, on Fridays. So let me know if you like it. If you have suggestions, please be kind and let me know what those are as well. Otherwise, I'll plan on continuing to do this for this foreseeable future. Hopefully, I'll have more like bigger chunks of work to show on Friday. As always, please support DigiKey, support DigiKey, but also support Adafruit. Support DigiKey because they're helping Adafruit out a lot. So you can buy Adafruit stuff through DigiKey. I like the unboxing too. I don't order DigiKey. It's kind of sporadic, so don't expect those. I don't expect unboxings kind of regularly, but let me know if you like it because I'm happy to do it whenever I get a box. Maybe I'll do an OshPark kind of OshPark envelope opening next week because I think I should get some next week. And let me know if that was interesting. It's just kind of like a random smattering of stuff and that's on my brain. I think that's mainly it. Have a great weekend, everyone, and I'll see you in our CircuitPython meeting on Mondays. On Wednesdays, I'll see you at Show and Tell. John Park has Show and Tell on Thursday as well. I think there's an early morning Show and Tell that Noe and Pedro are running on Wednesday mornings. They're East Coast, so I'm usually not awake. And then I'll do my stream on Friday next week. So thanks for all for hanging out, and we'll see you next week.